Hey guys, welcome to class. Today we're going to do lesson 3.1 part 2 where we're going to continue to solve two-step equations, but we're going to look at ones that also have negative coefficients. So I don't know if you realized that, but the other day when we were doing them, all of the numbers with the variable, the coefficients, were all positive, and so now we're just going to add in some more negatives, but we're really going to be following the same steps, so a lot of this should look very familiar to you. So let's look at this first example, and as we've talked about, I don't really like to solve these horizontally. I think they're a little easier to solve vertically. So let's go ahead and rewrite this over here to the side. All right, so if you would like, one of the first things you can do is make this addition. I think that's easier. I think you're less likely to lose the negative sign. Now, we've talked a lot about how when we solve an equation, we are undoing the order of operations using inverse operations. And so when we started this lesson, we talked about how we are typically going to add or subtract before we multiply or divide, and that is still true today. We're doing the exact same thing. So to solve this equation, the first thing that I would do is subtract 2 from both sides. Since that's a positive 2, and I want to try to get rid of it, I would subtract. So now 2 minus 2, that's what cancels out. And now here's the tricky part. I am left with negative 3x on that side, and that's why I think changing it to addition helps you make sure that you don't lose that negative sign, because that is not 3x. It's negative 3x. And then 17 minus 2 is 15. At this point, hopefully this problem looks familiar to you. Since it is negative 3 times x, we undo multiplication with division. And so we would divide each side by negative 3. Whatever I do to one side, I have to do to the other. And so I think that x equals negative 5 as my answer. And then we will jump over and use their check step over here. We can. So we're going to plug in negative 5 because that's what we think the answer is. I am still going to make this addition over here. And so I'm going to start with the multiplication. So negative 3 times negative 5 is 15, and 2 plus 15 is 17. So it worked out there for us. All right, let's try another example. Jump down to number 1. So as you look at number 1, again, I would encourage you to start by making this addition so that you don't lose that negative sign. Again, my goal is to get y by itself. I have to undo the order of operations. So since I have that positive 7, I'm going to get rid of that by minus 7. Whatever I do to one side, I have to do to the other. So the 7's cancel out, and I'm left with negative 4y. Again, that's the part that's new today, is you can't lose that negative sign. And so then I have 19 minus 7, which is 12. And so now to get y by itself, I am dividing not by 4, but by negative 4, because I want to get rid of that, not just the 4, but also that negative sign. And since there's multiplication, I undo it with division. And so then this would be x equals negative 3, I think, as my answer. And so then we'll check it just like we've been doing. And so in my check step, I start with the original problem. And I would encourage you in your check step to make it addition as well. So I am going to write that as 7 plus negative 4 times negative 3. You could also make it addition right at the beginning there if you want. So then in my check step, I follow order of operations. I do that multiplication first, and then 7 plus 12 is 19. So I see that it works out. All right, let's move to number 2. And I'm going to encourage you as you look at number 2 to think, since there's not a number in front of the n, what number are we allowed to put there? We've talked about this, that we can put a 1. And so I'm going to rewrite this problem as 5 minus 1n. And then I'm also going to make it addition from there. And I think adding that negative 1n is going to really help you in this problem. Because as I'm trying to get n by itself, the first thing I need to get rid of is that 5. Since it's positive 5, I'm going to subtract 5 from each side. And if you want over here, you can make it addition. So that's negative 7. But here's the deal. I'm not done yet. Because I don't have n by itself, I have negative 1n. And that's why I think putting that 1 there really helps you see that you still have a negative sign there that you need to get rid of, because we don't want negative 1n, we want 1n, or just n. And so now my last step here is, since there's multiplication, I need to divide by negative 1. And so the correct answer here is that n equals positive 7. And again, I think if you put that 1 there, it is easier for you to solve it. So then when I do my check step, I go back to my original problem. I have -2 equals 5 minus n. And so this would be -2 equals 5 minus 7. You could put the 1 there in the check step. You don't have to. It's up to you. I am going to make that addition, and I get 5 plus -7 is -2. So I can see that it worked out. But I do want to show you, you don't need to write this, but if you had not divided by -1 and said that the answer was n equals -7, which is not correct, but if you had messed up, which would be an easy mistake to make, hopefully your check step would help you because you'd have 5 minus -7, which you know turns to 5 plus 7, and that's where you would start seeing like, oh yeah, I've got a problem there. That's not working out. I'm getting 12 instead of -2, and so I know that this does not work. All right. We're going to pause the video right now, and I would like you to try number 3. So try to solve and check number 3, and then we'll play in just a second for you to see how you did. All right, check your answer to see how you did. You should have subtracted 6 and then divided by -2 to get the answer m equals -1, which then when you check that, put that back in your check step, you see that it does work out. All right, the next one that I want to do is number 5, but number 5, I'm actually going to change the problem because I want to show you something that's going to show up in problems on your homework and in the future, and we've already talked about it a little bit, but I want to see it in the context here of this problem. So we're going to kind of cross off the one that you see there, and I want you to put a negative sign in front of that fraction because I want to practice what we do when that's there. So we've talked about this, that when there is a negative sign in front of a fraction, that negative sign can go with the numerator or with the denominator. And when we were adding and subtracting fractions, we oftentimes put it with the numerator so that it wouldn't mess up our common denominator. Here, you could put it with the f. However, if you put it with the f, you're going to have an extra step because you're going to have negative f, and we don't want negative f, we want positive f, and so we'd have to divide by -1 because that would be like -1f. And so it is going to be a little bit easier for you to put the negative sign with the denominator, with the number, instead of with the variable. Now, we've talked about it can't go both places because a negative divided by a negative is a positive, so it can only go one or the other. I would encourage you to put it with the number. It just makes the problem a little bit easier. So now what I would do is I would add 8, since it's -8 or -8, whichever way you want to think about it. To get rid of it, I add 8, and I've got to do the same thing to both sides. And so then I have f divided by -2 equals -4. And so here at this point now you can see, okay, I have division, I undo division with multiplication, and I'm going to multiply by -2. And so what I'm doing there is I'm getting rid of not just the number, but also the negative sign, which is why it's better to put it with the number than with the variable. And so I get f equals +8 because I have a negative times a negative. So then when I come do my check step, you'll see here, I'm going to put that negative sign with the denominator again. Keep it down there. It'll just make the check step a little bit easier. So I'm going to plug in +8 divided by -2 minus 8 equals -12, and that's -4. And then I'm going to make this addition just because I think it's a little easier, and you could have done that in an earlier step too if you wanted. And so I end up with -12 equals -12 so that you can see it worked out there. All right, I want you to jump ahead now to number 9, which is the word problem. And we're going to practice a couple word problems that are now 2-step problems. So we've been doing a lot of 1-step word problems. Now we're going to take a 2-step word problem. And a lot of our process is going to be the same as what we were doing. So I'll read the problem. It says a group of 9 friends takes a whitewater rafting trip. The total price of the trip before any discounts is $810. Each person in the group receives a student discount. The total price with the discount, so after they got the discount, is $729. How much is the discount per person? write an equation to represent this situation, and then solve. Okay, so the first thing we need to do, just like we did before, is identify what does my variable represent. So I'm going to pick X. You can pick any letter you want. And typically whatever your question is, that's a good indicator for you that that's what your variable is representing. So when it says how much is the discount per person, that's my clue here that my variable is representing the discount per person. Okay? So now I want to think through the problem. And sometimes what I'll do is I'll even write out in words what's happening. So in other words here, I know they had a price before the discount, and then they got a discount taken away. Spelling that wrong there. Sorry, discount. Okay. And so if they're getting a discount taken away, that's my clue that that's subtraction. So they take away a discount, and that gives me the price after. Now, I'm not telling you that you have to write it out in words like this, but I do think this can help, especially when you're feeling stuck. So now, all I have to do is sort of plug in what I know. So I know that it tells me the price before any discounts was $810. And then we're taking away the discount. But X is the discount, but that's the discount per person. And we have to look and see, well, there were 9 people. So if 9 people got a discount, okay, let's think through how we could do this. So if, let's say the discount was $2, I'd be like, well, they got $18 taken away. Let's say the discount was $3, then they would get $27 taken away because I'm doing whatever the discount is times 9, which is my clue here that this should be 9D. 9 times the discount per person is going to give me the discount after, or the price after the discount. Okay, so there's my equation. And now to solve it, I'm going to subtract 810 from each side. And that cancels. That gives me negative 9D equals, okay, so I might have to come over here and do 810 minus 729. And you are going to have to do a little bit of borrowing. And so I get there negative 81 because the 810 is further from 0. I divide each side by negative 9. And I get, oh, I'm sorry. I switched my variable here to D. Sorry about that. I was thinking D for discount, which you could totally do. But really there, I originally picked X, so I'm going to go ahead and stick with the X that we did. And so X equals 9. Now I need to think, okay, what would my label be? And it would be $9. So the discount per person is $9. And then we could do a check step and plug that in. So I take my original equation, I subtract, I set that up there. I'm going to plug in what I think X is, which is 9. And 810 minus 81, that is 729, so that I see it worked out. Just as a quick side note here, if you're thinking, I would have set up this equation as the price after the discount plus the discount equals the price before, this equation would absolutely work for you as well. I'm sorry, I keep using D instead of X there, but that would absolutely work for you too. That equation would be just fine. Okay, so these equations are a little bit tricky, so we're going to do a little bit more practice with them. So what I'd like you to do right now is head to Shobi and grab the document that is called Lesson 3.1 Additional Notes, and you're going to move that to Notability. It has some more word problems that we're going to use to practice with. All right, so this is the document that you should now have. And again, this is just a few more word problems that we're going to practice with. We're actually going to skip number 1 because that's a one-step problem. So that'd be a good one to practice if you want a little more practice with these. But we're going to jump to number 2 because we're kind of right now trying to focus on these 2-step word problems. All right, so let's read number 2. At your local farmer's market, it costs $12 to rent a stand and $7 for every hour you stay there. If you paid a total of $47, how many hours did you stay at the farmer's market? Okay, so again, I need to identify what my variable is representing. So I'm going to say X equals the hours stayed. And you can say stayed at the farmer's market, but hours stayed is good. Okay, so now in this problem, what I'm trying to think through is what is varying or what is changing and what is constant, okay? Because I know here that I'm, however much it costs to rent and then stay is going to equal $47. So as I look at this here, what hopefully you see is that $12 is the constant. No matter how long you stay at the farmer's market, it's $12 to rent the stand. And so we've talked about how the constant is the thing that doesn't have the variable. And so this would just be 12. Now 7 is what is going to need to have my variable because it's $7 for every hour. And if X represents the hours, then I'm just multiplying those. In other words, think about it. If you stayed for 2 hours, you would pay $14. If you stayed for 10 hours, you would pay $70 because no matter how many hours you stay, you're multiplying that by 7. So that's why I'm representing that as 7x. That equals the total amount you pay, which is $47. And I hope this is obvious to you, but the 12 and the 7x could obviously change spots. So you could say 7x plus 12 equals 47, and that equation would work great as well. So now, as you work to solve this, I'm going to get rid of that positive 12 by subtracting 12. And that gives me 7x equals 35. I divide each side by 7 to get x by itself. And that's 5. I need to think through what my label is. And again, here's a good clue. When it says how many hours, there's my clue that my answer is hours. All right, then you'd come over to do your check step. I'd start with my original problem. I'm going to plug in what I think x is, which is 5. I follow order of operations, so I do that multiplication first. And 12 plus 35 is 47. So that worked out there for me. All right, let's take a look at number 3 to do another one. So number 3 says, during the winter, you charge people $12 for going to their house to shovel. Then $9 for every hour you shovel. If you make 57 one day, how many hours did you spend shoveling? Okay, so this problem should sound kind of familiar to the last one. All right, so X here is representing the hours shoveling. And just like before, we want to think through what is the constant and what is varying. In other words, of these numbers, which one is going to stay the same no matter how many hours you shovel, and which part is going to change based on how many hours you shovel. So I want you to think for just a second. You don't even need to pause the video, but just think for just a second to see if you can set up this equation. Okay, if you identified that 12 is the constant, that's great. 12 is the part that doesn't change. It's $12 to go to their house. No matter how long you shovel, they pay you $12. The 9 is what is changing based on how many hours you're there. If you go for 2 hours, you'd pay $18. If you go for 10 hours, you'd pay $90 because it's 9 times however many hours you're there. And that's going to equal the total 57. So if you set that up, good job. Again, the 9x and the 12 could change spots, no problem. So now I'm going to subtract 12 from both sides because I'm trying to get x by itself. I've got 9x equals 45. Divide each side by 9, and this one comes out to be 5 hours as well, which is kind of just random, but that they were both the same. Okay, and again, because it said how many hours, that's how I knew that my label would be hours. Then I'll do my check step. I start with my original problem. I'm going to plug in what I think x is, which is 5. And I get 57 equals 57, so I know I have the right answer. All right, as you head to the next page, we're going to skip 4. We'll look at problems like that next week. And let's go ahead and take a look at number 5, because it's another 2-step one. It's a little bit different. So 5 says 166 students went on a field trip. 3 buses were filled and 22 students traveled in cars. How many students were in each bus? So that's what my variable is going to be, is the students in each bus. Okay. So again, I need to think what part is constant or not changing and what part is varying. And I'd like you to think for just a second. No need to pause the video. Think for just a minute if you can think about how you would set up this equation. Okay, so if you realize that 22 is the constant, that's awesome. No matter how many kids are on the bus, 22 students traveled in cars. So that's the part that is not going to have the variable. Then if there's 3 buses and we don't know how many kids are in each bus, but there's some amount, that's going to be the part that has the variable. So it's 3 times however many students are in each bus is going to equal the total amount of students that we have here. So that's your equation. And if you said 3x plus 22 equals 166, that obviously would work great as well. So now to solve this, I'm going to subtract 22 on each side. And I've got 3x equals 144. Then I'm going to divide each side by 3. And that's something you're welcome to type into your calculator. That is 144 divided by 3 is 48. I then need to think about what my label is, since the question is how many students. I know my label would be 48 students. Then in my check step, I start with my problem. That is 22, and then 3 times 48. And again, you can type that into your calculator. 3 times 48 is 144. And so I get 166 when I add those two together. So I know I have the right answer. All right, those are the only ones that we are going to practice. There is a 3rd page to this. We are not going to do this. You are not required to complete this. You are welcome to use this for some practice as you're studying and preparing for our test, but you are not required to do the 3rd page on this. I just included it in case you wanted a little extra practice at some point, trying to practice finding the error in these problems. But this is where we're going to stop. And so what I'd like you to do at this point is go to Shobi. And you are going to grab the Solving 2-Step Equations Part 2 worksheet to begin working on now.